Over to one more important component, which is called operational amplifier. We will be having separate audio for this, but let me give an overview of how an operational amplifier works, because we'll be using in most of our projects operational amplifiers also. Okay, now let's delete all this and see how we use an operational amplifier. Let me have the switch and battery connection as it is, and let me go over to an operational amplifier. I take an operational amplifier like this, okay, and as usual, I have to give a supply to the operational amplifier. I give a supply to this like this, and I think one sec. Right. So what we have taken a well. So we go over to like this now. So we give a supply to the IC, positive, negative, and then we know that operational amplifiers can also be used as comparators. What is a comparator? A comparator is that when plus right. So what we were talking about an operational amplifier. An operational amplifier, we know it has got one non-inverting input, one inverting input, and one output. And such kind of operational amplifiers, in fact, in ICs are available either one operational amplifier in an IC, two operational amplifiers in an IC, four, like that. We have taken, for the convenience sake for our understanding here, one of the four operational amplifiers in a IC called LM339 or LP339. Okay, now let's see how it behaves when we start using it as a comparator. What is a comparator? A comparator is that, let's call it that if this is non-inverting input and this is the inverting input, and since this is denoted by plus and this is denoted by minus, so let me for convenience call it plus and minus. And the formula for the comparator is that when plus is more than minus, output is equal to 1. 1 means that the supply voltage, if the supply voltage is 12 volt, that means the pin number 3 I have given 12 volts here, then the 1 means in the output 1 means it is 12. Okay, so now let's go over to certain connections for it and let's see about it. Now let me take a, say, a 10k resistor, and I connect this resistor here, and okay, and connect this resistor here, and take one more resistor here, and then connect this to this and connect this to this. We have seen that is the potential divider of 10k, and supposing I give it to this point, I know this point will be, now if this is 12 volt, this point will be 6 volts because it is half the voltage based on this potential divider. Now let me take a variable resistor. Okay, or is a variable resistor? Okay, this is a variable resistor. I take a variable resistor and I take a variable resistor here, and let me connect it this way. That means the upper side is connected to 12 volt, bottom side is connected to ground. So that means when I vary this, this point can go to 12 volts or it can come to 0 volts, right? So let me make it at this point. I know this will be half, means 6 volts. So let me keep it slightly more than this, right? And now I connect it. Okay, if you are getting confused, so let me take it in a angle way so that you will not be confused. Right, now this potential divider which is above little 6 volts I have connected to here, that is plus terminal, and this I know is 10k and 10k, it is bound to be 6 volts. So that means this will be 6 volts, this will be more than 6 volts, output will be 1. Whether output is 1 or not, let's connect again a resistor here. Okay, let's connect a resistor in certain typical style, right? Connect a resistance here, and let me connect a meter also for that to see the voltage. I connect a meter here, I connect this to this point, and this point to say this point, right? And connect this to ground. Look it a little better. Let me do it. Okay, let me do it this way and this way. Now looks nice, right? So what is the function? Okay, this is a 10K resistor, as we know. Now let's power this and see what is happening. You see, now we know that this point is, if you want to know exactly what is the voltage here, I can connect some voltage probes here also. I put a voltage probe here, give a connection from here to here, and another voltage probe here, and give a connection from here to here. Okay, now let's power it. You see, this point is at 5.9933, means is close to about 6 volts, and this point is 7.19 volts. That means this point plus is more than the minus. Output is equal to high. High means 1 means supply voltage. Now if this changes to this, that means this becomes 4.7 volts. That means plus is less than the minus, but the minus remains same. When plus is less than the minus, output is equal to 0. So this is what is the basic function of an operational amplifier used as a comparator. We will see these functions in more detail when we go over to certain more complicated circuits. So this is what is the concept of using a potential divider, a relay, a transistor, an operational amplifier, and so on. So let's now clean all these and let's see how we go over to some more fundamental things which will be more clear, right?